Well, thank you all for coming to the Inamori Scholar lunch that we are offering. Normally you would be presenting this information to the Inamori Foundation and their representatives here at the university, but that opportunity usually comes during the Kyoto Prize Symposium, which is in the spring, which this year happened to fall in our spring break. So we wanted to find a way to honor you by presenting you the Inamori certificate of the Inamori Foundation's scholarship that you all are getting. And we'd love to have you then just talk a little bit about the research that you're doing as this particular scholarship helps to fund that work along the way. So let's go ahead and begin. Our first recipient is Macy Allen. Congratulations, Macy.
Thank you.
Here is the scholarship, and this is Dr. Cosmo Inamori, who is the person that started the Inamori Foundation and is the one who this commemorates.
Awesome.
So tell us a little bit about your work.
Yeah. My name is Macy Allen, and I'm working with Dr. Catherine Maloney's team this summer in natural products chemistry. So natural products are small organic molecules produced by living organisms such as bacteria or fungi. And we're working on citrus greening disease, which is affecting citrus orchards all across the southern part of the United States, and is especially prevalent across Southern California. So this summer, we're working on identifying ways to treat citrus greening disease by looking for antibiotics, the natural products, which are produced by bacteria and fungi living inside the citrus trees. This summer, we're also following up on data from the Tiny Earth chemistry course, which was taught at Point Loma from 2020 to 2022, in order to help identify new antibiotics that are being produced by soil bacteria. After identifying bacterial strains and fungi that are inhibitory of the disease-causing bacteria, this summer we're going to be extracting, purifying, and elucidating the structures of the compounds that we find.
Thank you, Macy. And next we have Noah Bradshaw. Noah. Congratulations, Noah. There's a certificate for you. And then you can tell us what's going on in your lab.
All right. Hi, I'm Noah Bradshaw. I'm at Dr. Nosal in his lab. This summer, our research involves both leopard sharks and taupe sharks. We just started last week, but we already have some plans outlaid for some possible projects this summer. One project involves leopard sharks, which involves looking at their behavior to understand why they leave the shoreline and come back in during certain times of the day and under certain conditions. To do this, we plan on using a drone to take survey photos of the shoreline during multiple days and different times of the day to hopefully understand this phenomenon more deeply. Another project we have with leopard sharks is looking at the ectoparasites that can be found on or in their skin. To do this, we plan on using a boat to go out during some days to catch the leopard sharks and collect the ectoparasites that can be found on their skin before bringing them back to our lab for further genetic analysis. In addition to these two projects, we are also studying taupe shark behavior involving diavertical migration, which involves them coming up to the surface during the nighttime and going back down deeper during the day. The reason we're interested in this behavior is while many sharks exhibit this type of behavior, taupe sharks exhibit a diavertical migration that is much more shallower and relaxed than other types of sharks. The reason for this is the focus of our research. Both acoustic and satellite tracking have been utilized to measure and collect our data. We're curious to figure out what causes the taupe sharks to move in this pattern and why they do so. With that, our lab is very excited for the summer, and we all hope that we can make some interesting discoveries over the course of our research. Thank you.
Thank you, Noah. All right, next is Bronson Fees. Congratulations. There you go.
Thank you. Hello, my name is Bronson Fees. I do biology research here under Drs. Wolburn and Durrell. And last summer we focused specifically on the human papillomavirus, or HPV, and we looked at a few oncoproteins and how we were able to change a point mutation in the amino acid sequence to basically revert a high-risk phenotype of HPV to a low-risk phenotype. And now, once we've completed that last summer, we're focusing now on to Merkel cell carcinomas, or the Merkel polyomavirus. So we're looking at broader viruses that cause cancer, and now we're specifically looking at mutating one of those oncoproteins that is produced by the Merkel virus, and we're going to try to change that to hopefully revert it to a phenotype that is not cancerous. Okay.
Thank you, Bronson. All right, next we have Nico Gamboa. Nico? Congratulations. There you go.
All right, so my name's Nico Gamboa. I am fortunate enough to be doing research with Dr. Ruffey this semester. So it's all about medicinal chemistry, a lot of chemical synthesis. So in particular, we know that malaria is one of the most devastating diseases that humanity has faced for a very long time. So a lot of what we're doing is trying to devise novel chemical compounds that interfere with the MEP pathway in the malaria parasite, specifically the ISPF enzyme. And so we're just trying to devise new compounds that are more specific and more active within that pathway to hopefully prevent the malaria parasite from being harmful and from spreading to uninfected cells, hopefully to become an effective treatment for malaria. Thank you.
All right, our next honoree is Vivian Grip. Congratulations, Vivian.
Thank you. I'm working with Dr. Manjarrez on a machine learning project to identify urinary tract infections in the bacterial colonies within cultures through just taking a picture on a phone. What we're doing currently is annotating the data to make sure that we can identify these different bacterial colonies and train a state-of-the-art machine learning program to identify these so that places where resources such as the fancy machinery or even the expensive testing to identify these UTIs are not available. This way, you will be able to take a picture of these cultures and the program will automatically be able to tell you, hey, this is what this bacteria is and this is what it's associated with.
Thank you, Vivian. All right, our next honoree is Jameson Hutman.
Hello, I'm Jameson Hutman. I'm working under Dr. Catherine Crockett in mathematics. Math's a little different. We don't really have like a research question per se. We're more studying a couple subjects, and if something arises, we'll look at it more in depth. But I'm studying topology, which is basically the organization of spaces without considering distance as we know it. So very abstract. And then knot theory, which is a branch of topology, which basically how we study knots. As simple as it sounds, it gets really complicated, and it has uses in chemistry and biology and things like that. So yeah.
Thank you, Jameson. All right, our next honoree is Ryan Ham.
Thank you. Hi, my name is Ryan Ham, and I am doing biology research with Drs. Durrell and Woolburn. We are researching a way to find a more targeted form of chemotherapy. It's called antibody-directed enzyme prodrug therapy. So we have an inactive form of chemotherapy that can be activated by an enzyme. This enzyme is naturally occurring in the human body so that it won't be rejected, but it has a single point mutation, so the wild type form of the enzyme will not activate our inactive form of chemotherapy. And this enzyme is attached to an antibody that has an affinity towards a novel marker that we found on tumor-associated macrophages. And these tumor-associated macrophages have been found in the tumor microenvironment of most aggressive forms of cancer. So the inactive form of chemotherapy would be administered to the patient, and it would go throughout the entire body, but it would only be activated at the site of the tumor when it reaches the enzyme that's attached to the antibody, which is attached to the tumor-associated macrophages. Thank you.
Thank you. And next we have Jacob Lee.
Hello. So over the course of last year and this year, I've been at the NIWC Information Center right next door, so that's the Naval Information Warfare Center, a part of doing some naval research in the environmental division. So basically, what the goal of our team was to help naval researchers choose an environmental model so that they could model contaminants in their system. So whether that's like mercury, PCBs, or VCOs. We didn't specifically make a new environmental model. We helped researchers choose out of all the dozens of models out there which best fits their needs. So it's almost like in Harry Potter, like the Hogwarts sorting hat or a personality test. You give the machine your constraints and what you're looking for, and we'll tell you, oh, this is the best model for your specific base. So yeah.
Thank you, Jacob. Is Michaela Ocampo.
So hi, my name's Michaela. I'm currently conducting research under the supervision of Dr. Mark Perry with a focus of methodology development in organometallic chemistry. Specifically, our work explores the use of transition metals as catalysts for important organic transformations. Using various ligand motifs and transition metal cores, we've been able to characterize electronic properties of these complexes via IR. And in addition, I have assisted in a collaborative project with Dr. Lawrence Beauvais, researching the design, synthesis, and application of N-metallocyclic carbenes, a new class of modular ligands. These ligands can be used to synthesize both bimetallic and polymetallic complexes with potential applications as both catalysts and functional materials. And we're finishing some data so that we're able to fully characterize some of our complexes in hopes for a publication. And we're also hoping to launch some magnetism studies and electronic communication studies in the near future to help study these carbene complexes further. Thank you.
All right. Well, congratulations, everybody. You are one of 3 groups that typically get honored at the Kyoto Prize Symposium that's held here in the spring. First, obviously, is for the laureates themselves, and there's a presentation of the laureates at Kyoto in November, and the prize was developed and organized by Kazuo Inamori, who was part of the Nobel Prize selection team, and he recognized that there were certain areas that Nobel didn't ever recognize. And so those were advanced technology, basic sciences, and then arts and philosophy. And so he, with their permission, created this prize. And one of his philosophies is that he believes that it's the best use of our time is in the advancement of humankind and the betterment of humankind. And so the work that he is doing in honoring, and the foundation is doing in honoring these laureates, is to recognize work that has been used for the betterment of civilization and betterment of humankind. And so part of the thing that they try to do then is they say, well, what are some college students who are at the front end of their career versus these laureates? And so hopefully the work of these laureates is inspiring the next generation to come beyond that. So you're a part of that next generation. And then also there's high school students that are honored during this time. And so there's several high school students that are from the Tijuana, San Diego area that are given scholarships as well as they are beginning to enter into college. So I love the kind of the full picture of that. Those who are already accomplished and have succeeded in many of the things that they're doing, and then also the ways in which they're trying to inspire a younger generation to come along behind them and continue that work. So congratulations on being part of that younger generation, and hope that the work that you continue to do will have an impact on the betterment of humankind moving forward.